She is currently the Assistant Director of Fuels and Fire Ecology for the Forest Service, Southwest Region. Emily began her career with the Forest Service in 1986 on the Coconino National Forest in lands and minerals as a co-op student. After several years, Emily accepted a fire management trainee position in the Forest Supervisor's Office. In 1994, she moved to the Gila National Forest as a field specialist. And in 1997, she accepted the District Fire Management Officer position on the Wilderness Ranger District in the Gila. In 2002, Emily moved to Albuquerque as the lead coordinator at the Fire Use Training Academy. And in 2009, she accepted her current position. Emily has worked on the Wildland Fire Management Team since 2000 and is a planning section chief on the Northern Rockies Wildland Fire Management Team. And she has a degree in forestry from NAU. So everybody, please welcome Emily.
Get some things set up here a little bit. All right. Well, it is a pleasure to be here this morning, and it looks like a great crowd. And I'm going to spend this morning a little bit of time with you talking about ecological thresholds relative to fire. And there's three main topics I would like to cover. And one is the ecological thresholds. One is going to be some of the challenges the agency faces based on departed conditions, and then some thoughts about how we can go forward. So let's start this morning with a general discussion of the historic landscapes and the role of fire. And then we'll change gears and we'll talk about what's occurring across our landscapes today. So historically, the Southwest area had two types of fire systems. They were fuel limited or they were climate limited. So some of the characteristics of a fuel limited system is there was frequent, low severity, non-lethal fires, and these were often associated with ponderosa pine and mixed conifer vegetation types. And so it's commonly referred to as we had surface fires out there. The disturbance patch ranged from very small, like a single snag, 1/20th of an acre, to well over 2,000 acres. And these patch sizes were very variable across our landscapes based on the fire frequency and a lot by the moisture that had occurred during that year. The fire frequency across the Southwest area ranged from anywhere from, based on historic records, 2 to 30 years. That was the frequency. So let's look at some of the characteristics of a climate limit system. And these are infrequently, predominantly mixed severity, high severity fire regimes. They're lethal fire regimes, and they're associated with the wet mixed conifer and the higher elevation spruce fir forests. We often see the type of fire in these forests as ground fire versus surface fire. So the research on the patch size is not very good in these climate limited systems. However, we think it was probably variable, and the larger patch sizes were found on the north and east facing slopes where you had heavier fuel loadings. These climate systems historically did support heavier fuel loadings, and climate truly was the driver when they were available to burn. So we've had tree ring studies conducted across the Southwest area, and what the tree ring studies have done has recorded evidence on fire frequency and fire size. So what I have shown here is a fire history reconstruction of ponderosa pine, a tree ring study that occurred on the Tono National Forest below the Mogollon Rim, and the elevation ranged from about 5,500 to 7,000 feet. The study area was about 2,500 acres, and the years of the study were ranged between 1725 and 2000. So the horizontal lines that you're seeing here, that run this way, represent individual fire-scarred trees. The ticks, these vertical ticks that you see all through here, represent individual fire scars on this study. So what this study is suggesting is that from about the year 1900, there it is, from about 1900 to present, the evidence of fire across this ponderosa pine landscape is absent, or relatively absent. However, if you look prior to 1900, you can see that the fire frequency was approximately every 1 to 2 years, and that the fire size reported was about, again, very small, 1/20th of an acre to 250 acres. This is every 1 to 2 years. So we had a lot of frequent small fires. Every 2 to 6 years, this site recorded fires that ranged anywhere from about 250 acres to 1,200 acres. Every 3 to 10 years, this site reported fires greater than 1,200 acres. So this frequent fire regime resulted in a fuels-limited system in the ponderosa pine. So again, studies have been conducted across the southwest area, and in the ponderosa pine and the mixed conifer, all the studies are pretty similar, and they're pretty consistent in that we had a very frequent fire regime, again, anywhere from 2 to 30 years. So historically, ponderosa pine and dry mixed conifer stands had less shrubs and they had more herbs. The historical accounts describe more grass and open conditions. We had low severity fires, and we were in a fuel-limited fire regime. Shown here is a historical fire frequency that was developed by the TNC, the Nature Conservancy, for the southwest area. And as you look at this, the red is characteristic of a high fire frequency regime. And you can see much of the southwest area historically was captured that way. And you can see that include the Mogollon Rim area here, you know, the ponderosa pine along the Mogollon Rim, the Sky Islands down here, excuse me, on the Coronado. You have the Lincoln over here, and to some extent up in northern New Mexico. And then you have the grasslands of southeastern Arizona and southeastern New Mexico. The orange shown here is more of a moderate frequency. It was a little more infrequent, and you can see that was captured in the Four Corners area, where if you think about when you drive through there, you've got a lot of pinyon juniper and mostly pinyon juniper. So it was more of an infrequent fire regime. And then you look at the blue and how this is captured as a variable fire regime. And so it was really low frequency. And you can see that's the Sonoran Desert over in southwestern Arizona. Over in here you can see the Missile Range in New Mexico and some of the very high elevation mountains in northern New Mexico. So tree ring studies, pictures, and written accounts provide land managers a really good picture of what historic landscapes look like in the Southwest, and as importantly, the role of fire. Now this is a picture that was taken at noon near Greer, Arizona on the Wall of Fire. So let's transition to the past and talk about conditions today. So what's going on in our fuel-limited systems, our ponderosa pine, dry mixed conifer? They're characterized today as departed. There's an abundance of surface and aerial fuels. There's an absence of frequent low-severity surface fire, and this is evident through the tree ring studies. And we're seeing changes in fire severity from non-lethal to lethal, and the patch size of these lethal fires far exceeds what was believed to have occurred historically. Climate-limited systems, let's talk about the characteristics today. And overall, they were characterized as not being quite as departed relative to their fuel loading, their fire severity, and their fire frequency. But where we're really seeing changes across our landscape today have to do with the patch size. And so these fires in this wet mix conifer and these spruce fir forests have the potential, and we're seeing this, we're realizing this, to burn large patch sizes of mixed to high severity fire. And this is occurring partially because we have a lack of distribution of smaller fires out there across the landscape. Also, the adjacent forests. So when you look at the dry mix conifer, the dry mix conifer is burning just like the wet mix conifer today. So the patch size becomes much larger, and they're burning at the same severity. So as climate change continues to unfold in our lifetimes, the wet mix conifer and the spruce fir forest will potentially burn more frequently than what probably historically occurred, and with much larger patch sizes. So here's a snapshot of recent wildfires across the southwest area from 1984 to 2012. And what this picture is showing in today is that you can really see is we have a lot of high severity, large patches in the Mogollon along the Mogollon Rim. You can see what's going on down on the Coronado with the Sky Islands, and you can see some of the large patch, high severity fire in northern New Mexico. So ecological conditions across the Southwest are challenging land management agencies. And they're often these conditions are influencing fire management decisions and our decision space. So I'd like to highlight some of these challenges that land management agencies are faced with today. And here's just an example of a satellite photo taken of the wildfire on June 7, 2011. And I think we all know that occurred on the Apache Graves National Forest. And I want to talk a little bit about smoke as a challenge to both the public and our firefighters. So here's an example of smoke emissions coming off the Wallow fire into the greater Albuquerque area where we have a smoke monitor. And the blue that you see here are the cumulative acres. So the final fire size was right at about 500,000 acres. The black dotted line here is the 24-hour standard set by EPA for public health. And we can see from the recordings off the monitor, the yellow bars here are the number of days where the air quality in Albuquerque exceeded national standards. The red bars are the peak readings, a 1-hour peak reading in this 24-hour time period. So you can see we had multiple days in a row in Albuquerque where we exceeded air quality standards set by EPA. Now the fire history in the Wallow fire suggests that only about 10% of that landscape had a footprint of fire, and over the last 100 years. And the smoke coming off this event obviously impacted Arizona, New Mexico, Colorado, and monitors picked up air quality recordings all the way back into Ohio and further east. Now, based on my experience in the agency and in the positions I've held, I think people have a tolerance for smoke for about 3 days. And it's only nuisance smoke. It's not exceedance of standards. We're talking just nuisance smoke. And after that, the general public wants smoke to go away. Now, that's going to be a challenge if we're going to reintroduce fire across our landscapes. And conditions across Southwest area landscapes today set the stage for significant smoke impacts. And this has been evident by the Los Conchas fire, Whitewater Baldy fires, and Little Bear fires just recently. So wildfires have really captured the attention of the media across the Southwest. And wildfires are often the leading stories, whether it's in the newspaper or it's on the 6 o'clock news. Ecological conditions set the stage, I believe, for similar headlines into the future. Fiscal challenges across all agencies are being realized. And what this graph shows here is the 11-year suppression costs for wildfires on Forest Service lands in New Mexico and Arizona. The white line is the trend line. So what happens when we spend too much money trying to suppress fire is we go into a thing called fire transfer. And that fire transfer occurs when suppression costs exceed the national 10-year average. And so when we exceed that average, what happens is that money is taken out of other program areas within the agencies, and it's transferred into fire to pay the bills for fire suppression. So when we do that, we reduce the services, the activities, and restoration efforts across our agency. And this occurred in 2011 in the Southwest area and nationally. So ecological conditions coupled with drought and warmer temperatures really do set the stage, I believe, for more large, very costly wildfires. Because land management agencies are committed to protect WUI, livelihoods, and natural resources from uncharacteristic fire. Again, suppression costs will continue to be a concern, and this graph here shows that in the Southwest area, we're burning more acres and we're having more large fires. And this is really evident if you look at just the snapshot here in the last 10 years, that trend is increasing. So land management agencies are also challenged with organizationally. And I would like to just look at two of the lines on this graph, and we're going to talk about fire complexity and operational capability and how they're trending in different directions. So fire complexity is this red dotted line here, and let's focus on that first. So fire complexity followed a trend at the turn of the century as being moderately complex. We had large fires across the western United States, and many of us are familiar with the 1910 fires in Pulaski. These posed problems, and as a result of that, there were development of fire control organizations. But then you can see during the middle of the century here that fire complexity decreased. And that was because this was probably some of the wettest, coolest periods of time since 1900. But then you can see in the 1980s, drought conditions start to come into effect. We have altered fuel complexes, we have urban interface, we are beginning on the cusp in our fire environment to see very large, high severity fires and large patch sizes. So what this graph is suggesting is that the fire complexity will continue to trend upwards into the foreseeable future. So now let's compare that to what the organizational capability is. And let's look at this green line right here. And so organizational capability at the turn of the century was initially very low. And this was evidenced by such things as budgets, staffing levels, equipment, and resources. But then you can see right about here in the 1940s, we have this really peak, this upward trend in our organizational capability. And that's directly resulted to the CCCs from the Depression years. We come out of World War II, all of a sudden we have aircraft to help support fire suppression efforts. And there is a period of time that many of us lived through that we could actually overpower fires. We could put them out, and we could do that successfully. And you can see that until about 1980. And then what happened is that the fire environment became more powerful than the organization's ability to respond. So organizationally, into the future, we will not be able to overpower wildland fires. One more crew, one more air tanker, one more helicopter, one more engine will have a very minimal effect on the outcome of large fires. And this is very evident from what we saw in the 2011 and 2012 fire seasons in the Southwest area. So in summary, ecological thresholds have cascading consequences. And this is just maybe the tip of the iceberg, what I have up here on this slide. So it begs the question, what are we going to do? What are our options when we look at ecological challenges into the future? And I would suggest, based on my experience, that in these fuel-limited systems, these ponderosa pine mixed conifer systems, the footprint of fire will become more and more important relative to severity, future severity of wildland fires, and costs. Simply stated, we need more fire. So let's look at some of the reasons why. So the footprint of fire and frequent fire regimes is very important relative to anticipated severity of future wildland fires. And so recently an analysis was done in our region, and the data looked at 10 years of fire history across all the national forests. And then we looked at the 2011-2012 large fires, 25 fires greater than 5,000 acres, and what happened when they interacted, fire history with the fires that occurred during those 2 years, relative to severity, spatial extent, and the cost of suppression. So let's talk about severity first. And what we have on this x-axis is basal area, percent loss of basal area. And what we have on the y-axis is severity. So if we look at the red bars here, this is where fires did not burn into old fire footprints, so into any of the historical fires. And what we see here is that we have less acres of low severity fire, and most of our acres tend to be high severity fire. Now just the opposite of that is if you look at these green bars here, and you can see that when we had fires in 2011 and 2012 intersect with fire history, we see much more of the acres in this low severity, in the low severity range, and a lot less acres that burn in high severity. So let's look at a couple examples of that. And here's the Whitewater Baldy Fire from the Gila National Forest, and let's look at the severity here. Now, I don't know how well you can see this, unfortunately, but one thing that needs to be pointed out is the rich fire history on the Gila National Forest. So this is the 10-year footprint of fire down there in the wilderness. And then let's look at severity. And the severity is captured here on the west flank of this fire, where you see the large red patches of high severity fire. And they are large and they are continuous. But when you start looking over here on this western flank, there's not a really good footprint of fire over there. When you start coming across this area here in the middle of the fire, you see a strong footprint of fire, and this is where we transition from higher elevation species to the ponderosa pine. And you can see the outcome of the severity here was predominantly low severity. And then when the Baldy fire, the Whitewater Baldy fire, ran into the Miller fire, which is down here in the southeast corner, it went out. It was fuel limited. So let's look at the ponderosa pine in particular and how important that footprint of fire is. So here, shown here are the acres burned by severity class for the ponderosa pine. And approximately 70% of the ponderosa pine in the Whitewater Baldy fire burned at low to moderate severity. 30% of it burned at high severity. Again, there's this large portions of the Gila wilderness that have a rich fire history, and they became fuel-limited systems. So here's another picture of the Whitewater Baldy. And this picture was taken in dry and wet mixed conifer. And you can see that this was a very high severity burn footprint here. And high severity is not necessarily bad, but it really does depend on the location and the size of the patch. That's very important. And the absence of fire in that very west flank of this fire resulted in this high severity patch. I mean, there was limited or very little fire history on that side of the fire. So as a result of that, we saw the dry mix conifer and the wet mix conifer burn in very similar, at very similar severities. Another example of the importance of fire history as we go into the future is the Miller Fire. And the Miller Fire was down on the hill, and it burned in 2011 also. And it burned, 2011 was a big, big fire here in the southwest area. And this picture was taken in June. So let's look at this specifically. Now let me point out a few things. Up here on this north flank, that's the west fork of the Gila. Over in here is the Gila cliff dwellings. And this area down in here is the Gila River corridor. So again, you can see all the blue in this area in here. And that's the fire history on the Gila National Forest. And then you can see there are patches of high severity fire down here in this southeast corner. But if you look at the patch size and the severity, there's a little more mixed severity there. You see some yellow starting to come in. There was fire history in the southeast corner of this fire. And that's why we're not seeing as large a patch size, and we're seeing the mixed severity. When we go up to the Gila cliff dwelling area, you see a lot of high severity there. And if you're familiar with that area, there's a lot of pinyon juniper up there. So you go into the middle of this fire here on the Miller Fire, and you predominantly see low severity. It burned, it interacted with a fire scar. So let's look at let's look at some of the severity on the Miller Fire. So when we look at the pinyon juniper woodlands up there by the Gila cliff dwellings predominantly, about 50% of that burned, the pinyon juniper burned in low to moderate fire severity. The remainder of it burned high severity. And pinyon juniper is a mixed severity fire regime. So this probably was similar to what historically would have occurred under the conditions this fire burned in. So shown here is severity for ponderosa pine for several large fires that occurred in New Mexico and Arizona over the last couple of years. So thinking back to the Miller Fire, in the ponderosa pine, approximately 70% of the acres burned at low to moderate severity. Now when you compare that to Los Conchas, which was up here north in the Jemez, and over on the Apache Sitgraves or the Wallow, only 40 to 45% of the acres burned in low to moderate severity on those two incidents. And again, there wasn't the rich fire history in those two systems. So I believe the footprint of fire as we move forward is going to be very important if we want to reduce the severity of future fires. So into the future, we've got all kinds of people living in the Southwest, and we are going to have to learn to live with fire and smoke. And the land management agencies have a limited control over smoke, and some of the ways we can address that is how we respond to fires, our tactics and our strategies. But the bottom line is smoke is not going away, and it probably will only increase. So to help address this social challenge, the agencies are working very hardly with the air quality bureaus and the health departments to be able to communicate what those potential impacts are going to be and the associated health concerns. So shown here is a product that's developed out of our predictive services office, and it's really a way that we're trying to proactively communicate smoke and smoke impacts so people can make personal choices about their health and be able to live with fire. So fire history relative to costs, suppression costs, important, very important in the agencies. Let's take a snapshot of how important, again, I think the fire history is going to be to help drive down fire transfer. So again, this recent analysis did take a look at that. And so it was the same data set, and then we compared it to the 2011-2012 fires. And so what these results are suggesting is that there's some real predominant breakpoints here. And this is your cost per acre and your percent perimeter. So how much of your perimeter burned into a fire scar, an old fire scar, in the last 10 years? And roughly, as about 25% of that fire burns into an old fire scar, interacts, you can see the suppression costs decrease pretty significantly. Over here, we looked at the percent of acres that burned into an old fire scar relative to cost. And there's a break point here. So if roughly 30% of the acres on an ongoing fire burned into a footprint, had that interaction, you can see costs decrease dramatically. So I think fire history is going to have a direct effect on suppression costs, and the greater the interaction on that landscape, the less maybe we will spend trying to suppress fires. And that's really important because it won't detract from other activities and services land management agencies are trying to provide to the public. So here's just a manager's translation. Here's the simple numbers. So we have an organizational capacity issue within our agencies, and I think it extends well beyond just the Forest Service. We don't have the people or the equipment to put out every fire. But what we do have is we're pretty smart people. We're intelligent. And we have the ability to critically think and to work through challenging situations collectively. And so in agencies, in federal land management agencies, there's been tremendous efforts put into risk assessments and risk management. Forests and all agencies are looking at when we respond to a fire. Are we responding appropriately? Are we using the right resources? Is this the right time for a fire? Is this the right location? And what are those values out there that we really need to protect? And that we don't always have to fully suppress every fire across our landscape. Forests in the southwest area do not want to avoid risk. They don't want to transfer this landscape on to their predecessors. So we know that putting out all fires is not sustainable, and it's inefficient, and it's costly. So to be successful, we're all into this together, and that communication and partnerships with all agencies and the public are just ongoing efforts that are very important to be successful in the future. So I focused a lot this morning on the unplanned, the wildfire side of the house. And Bobby alluded to this earlier. Our agency is putting tremendous effort on the planned side of the house, our planned program and activities. And we've got multiple large-scale restoration efforts going on across Southwest area forests and all lands. Those include the Fry effort over in northern Arizona. We have Southwest Tavis just to the north of us here. And over in the Zuni Mountains, south of Mount Taylor, there's a big restoration effort going on also. And we're trying to restore these landscapes to be resilient to fire into the future. So we've got restoration efforts going on, but we also have hazardous fuels programs going on. And though those are similar, they're somewhat different. And we have a hazardous fuels program in the region that's primary focus is to protect communities and people and livelihoods. So forests are strategically implementing hazardous fuels projects. They're thinning, they're burning, they're removing biomass to achieve these objectives. And the strategy here is that because this is our planned program, and we only get a limited amount of money to do this, the strategic placement of those treatments is critical so that we can open up more landscape to use fire. The forests are prepared to do this. All the forests in this region have undergone land management plan amendments so that they can further utilize fire across their landscapes. So in summary or conclusion, we've talked that the southwestern area has just a variety of fire regimes. Historically, we had a lot of fuel limited systems, and we had some climate-limited systems. And in the light of climate change, it's going to be very important as managers and people who really care about the land and the resource to reestablish fire in these fuel-limited systems. We need more fire. Integration, it's important, and it's encouraging to see and to be part of a workshop that's actually not talking just about, I don't know, animals. And we're talking about fire, and that integration at the local level is, and across agencies and with the public is so important to really understand and communicate the magnitude of land management issues that we all face and that are all very important to us and to our kids. We have to be champions of fire. And we know, and we don't know, but we have strong reasons to believe that that fire footprint is good for about 10 years. And it's critical that in these fuel-limited systems that we get more fire introduced. You know, it's only good for 10 years. We've got to get more fire and maintain that landscape once a fire's gone through there. Because we feel pretty confident it's going to affect the future severity of wildfires, and it could drive down our costs. Partners are critical, and they're very important. Partners are needed so we can speak with one voice on issues that challenge all of us. Internal and external education about fire. You know, I guess I look at that as the gift that keeps giving. You know, you get a good rapport with people from other agencies, or you get good relationships with your public, and then they take jobs, they retire, and they move on. And so it's just a constant communication and developing partnerships and relationships, because we truly are in this together, because we have to live with fire in the Southwest area. And applied fire research, I just think there's tremendous opportunities to look at landscapes before they get to the state that we saw on the opening slide this morning, where you've just a high severity event, and now let's look at and research that. Help land management agencies to do applied fire research before the fire. And I think two areas that are not well addressed and researched right now have to do with future fire severity relative to the fire footprint and how that drives down costs into the future. So, I guess the challenge, and you've had a lot of challenges already thrown at you this morning, are how are we collectively going to manage these systems as we go forward. And I heard a very prominent person speak at a class a couple weeks ago, and he said it's a lot easier to take fire out of the system than it is to reintroduce it. So again, I appreciated having some time with you this morning, and I guess I have time for maybe a couple questions. Oh no. Okay, yeah.
Have you started thinking about doing controlled burns in the Rodeo Chettiskai fire? It's been 11 years now. And what would the locals think of that?
I can't necessarily speak to the locals, but there are planning projects going on right now to go back into the Rodeo Chettiskai footprint and reintroduce prescribed fire. Good. Yes, there are.
Well, I have another question too. Has anybody looked at the contribution of CO2 into the atmosphere of these big fires compared to the domestic energy production from fossil fuels, per year?
I can't answer that. I don't know. Have you? I don't know.
It's an interesting.
Is your agency looking at mercury emissions from these fires and stuff?
Gosh, I'd like to say I'm sure we are. I don't know.
Could you repeat that question?
The question was mercury emissions in the smoke produced from some of these large fires. I don't know. Excuse me?
I gave you a study. I think it's quite low.
Oh. So it sounds like there are some studies available out there. Yes.
It seems like some things we can do what we have control over. And there's a Forest Service going to stop smoking in the airport. That's part of your education. But it hasn't even looked hard to
Yeah, the question had to do is the agency gonna put an end or somehow change the message to the Smokey the Bear program? I don't know. That's a topic, that's a philosophical discussion that occurs a lot in our office. I work in the fire group downstairs, and we sort of probably believe that had a time and a place. However, when you think back originally to the messaging with Smokey the Bear, it really was initially focused on stopping human-caused fires. And so I think that has a very important role, because many of the human-caused fires in the southwest area that have occurred in the last decade have occurred in May and June in really extreme conditions. And so it's a good question. I don't know. We talk about it a lot.
Let's give Emily a hand.